Hello class, welcome to Unit 9, Day 11, and today we are talking about the Pythagorean identity. Now, the Pythagorean identity is just a version of the Pythagorean theorem dealing with the unit circle. So we have a triangle formed on our unit circle. We know that this point, xy, is cosine sine, and that had to do with the hypotenuse being 1, so when this side is y and this side is x, from the angle theta, this becomes our opposite, so it's y over 1, and this is our adjacent, so that's x over 1, which is why those are what they are. This was our hypotenuse. So logically, cosine squared, or x squared, plus sine squared equals 1 squared, or 1. That's where this formula comes from. Okay, so that's our identity. We could do that wherever we drew the triangle. And because everything gets squared, even if the number was negative, as it would be in this case for x, it'll become positive. All right? So that's the formula. It's just a squared plus b squared equals c squared. It just happens to be that c is 1, so it doesn't really matter, once again. So what we're going to do, can I move this over? I think I have a way to move things. So if I take this, I should be able to move that over. I'm learning new features on this iPad. Move that over here. All right, now, if I were asked to find sine square theta, all I would have to do is subtract the cosine square theta to the other side. So I would get 1 minus cosine square theta. That means in any problem where I don't want to have both sine and cosine square theta, I can replace all my sine square thetas with 1 minus cosine square theta. Similarly, if I wanted to get cosine square theta by itself, I could just subtract the sine square theta to the other side and get 1 minus sine square theta. And you'll see that comes up in some of the problems in the homework examples. So let's go down and take a look at one of those. It's actually over here. For instance, we're told what sine square theta is in a problem, but we have the Pythagorean identity. So that means you can replace the cosine square theta with the 1 minus sine square theta to answer the question. All right, so I'm not going to get into that any further. You can try that yourself. Other things we need to know is, where's this tan square theta coming from? Well, all of these things are coming from the same original formula. If you remember, tangent is equal to sine over cosine. Very important to know. And we also need to know that cotangent would be the opposite or the reciprocal of that, so cosine over sine. We also need to know that secant is 1 over cosine. Cosecant is 1 over sine. These are not new. We've done all of these before. And cotangent is 1 over tan. Those are the reciprocal functions. These are also identities. This is an identity, and this is just the reciprocal of that. All right, so we're going to use that here. So we're going to start with sine square theta plus cosine square theta equals 1. So I want to change this formula so that it has tangent in it. To get tangent in it, I need to divide this by cosine square theta, because this is equal to tan. Now I'm not allowed to just divide one part of my problem by cosine. I have to divide this part as well. Left out the theta here. Cosine square theta divided by cosine square theta is equal to 1. And I have to divide this by it as well, so cosine square theta. Now 1 over cosine is really secant, so this is really secant square theta. So now we have the formula for secant. So this is tan square theta minus 1. And we can use this to find all of the other ones. So if I wanted to get tan square theta by itself, I would just add the 1 to the other side. I get 1 plus secant square theta. For cosecant and cotangents, I'm just going to take the identity function, and divide it by different things. So if I wanted cosecant, I would need to get a 1 over sine at some point. So that means where I have my 1, I would divide by sine instead. So for cosecant, so let's say I do, we have sine square theta plus cosine square theta. So you really only need to know this one, and then you can just find the other ones using this idea. So I want cosecant. So cosecant, I need to divide this by sine. So sine square theta. That'll make this into cosecant square theta. I'll have to do the same thing here. And cosine divided by sine, as we said, was cotangent. And sine divided by sine is 1. So 1 plus cotangent square theta is equal to cosecant square theta. Knowing that, we should be able to find the other ones. So we know what cosecant square theta is. It's 1 plus cotangent square theta. And cotangent square theta would just subtract the 1 to the other side. So we will get cosecant square theta minus 1. All right. Okay. So that's where all these formulas come from. It's just manipulating the original formula by either dividing by sine, cosine, or sine or cosine, and then isolating the value you're looking for. So every time you see one of these in a problem, you can replace them with their equivalent value. Oh, this should say 1 plus. It's really unclear. Whoops. Went back to the wrong lesson by accident. Whoops. Uh-oh.